This time we're going to be talking about branching code, and there are 6 different ways that code can be branched, and we've covered a couple of them already, but I'm going to go through the other pieces. So the first one is the if-then statement, and we saw that in an earlier video. It's probably the most intuitive way of branching code, and it's just a case of putting in a line which tests the truth of a statement. If it's true, then you run one lot of code, and if it's false, then you can run a second set of code. The next way of branching code is the select method. Now, this is very similar actually to the if-then statements. The only difference is that instead of just having a binary kind of thing where you have either true or false, you can have a variety of different results. So it might be that you selected on the value of a particular cell, and then if it had a particular value, then you ran the case of a first value in case of a second value, and then in case of all other values, which is case else. And since it is so similar to the if-then statement, I don't actually propose to explain it further here, and you can see examples on Google in any case. Now the goto command is very straightforward, and it's a little different to some of the other branching methods that we've been looking at. It's not conditional. You just put it in your code and you go to a separate line. Now I'm going to show you how this works in an example in a little while, which will bring in the next 2 methods of branching too. And it shows you the issue of naming lines as well, so that's going to be quite nice because we'll see how those things work together. When it's useful, it's really useful. You don't use it very often. The on-error method of branching is another one of these ones where when it's useful, it's really useful. It's kind of strange because it only works when the macro crashes, and so what you can do is you can use it to rescue the macro, and quite a lot of people who are keen programmers think that this is good practice to always rescue the macro. I kind of think that if the macro is crashing, that there's nothing wrong with just letting it crash, and you get an error message, and the developer of the macro can then work on it and then improve it and make it work. But sometimes you can use this in two main ways, really. I think one is where you have a crash and you really don't know why it's happened or where it's happened, perhaps in the code. You can actually build your own error message up, and again I'll show a little example of how this might work in the example coming up. And you can then pass to the user and then the developer of the macro all of the data which has been accumulated in the macro up to that point, and it can help you really debug it. The other time that I've used this and it has proved very useful is when I've been writing a macro which pulled in data from a different source. So I was getting some data from I think it was pricing or something like that, and when the data came in, if the format of the data was as expected, the macro would run perfectly well. But every now and again, the person who's producing that data wasn't perhaps as careful as they might have been, and so some of the columns had the wrong type of data in it. So I can't remember, perhaps there was numbers in text fields or vice versa. So I put this line in to catch those errors, and I could point to the user to go back to the producer of the data and tell them where the data had been incorrect. So it meant that in that particular process I could stop it, go back to the data the source of data which was before the macro ran, and get it correct to the source, and then we could let the process flow through again properly. Now the and is a funny sort of branching again. It's just as it says, it's a way of stopping the program flow or the script flow. There's an alternative way to do this, which is of course just to write a goto, and you can do the goto to the end of the script. But sometimes it's just easy just to do a full stop. And I'll talk more about this in the example that's coming up. VBA allows you to call subroutines. That means one routine can call another one. That's why the brackets are in the sub command, so that a subroutine can pass variables from one subroutine to the other. So why would you do this? Well, a pure programmer would say that you can use a subroutine where there is something which is being repetitively done, and it can be called by another macro in several different places. And that does happen occasionally. However, the most common use that I make of calling subroutines is merely to break down the macro into chunks. Some of these macros can be hellishly long, and if you can break them into logical steps, and then you can have a kind of master subroutine which is calling one by one the other subroutines, and you can easily see what is going on when you're reviewing this after a month or two. And that's what I've used that for too. I'm going to use the spreadsheet that we've been using on the last few videos, but I'm going to use a new blank page. What I thought I'd do is run a macro that shows you how some of these branching ideas worked, and in particular I'm going to be using something which picks up on the on-error command. And what I'm going to do is just take a list of numbers, and I'm going to find the square root of them. And I'm just going to put a list of 5 numbers in this spreadsheet, and that's going to be our test data. I'm now going to open the Visual Basic editor. I think I'll start with a new module, so I'm going to right click here, insert a new module. I'll name it Okay, we'll go and see if this will run now. Okay, I've obviously made an error here, but it's quite easy to see what it is. It's I put the bracket here in the wrong place. What we'll do is we'll stop the macro to run. This yellow thing here says that it's found something in the whole of the macro which is wrong. That's why this has been highlighted here. Otherwise, if it found an error in a particular row, then the row would be highlighted in yellow. But I'm going to stop and go back to this spreadsheet and actually run the macro from there again. So now you can see the yellow highlighter has disappeared. Also, I noticed this if-then statement. I've got the wrong way around. I want to put a value into the cell to the immediate right of the current cell if it's blank, and if it's not blank, so I need to change that to equals. Let's go back to the spreadsheet and see if it will run this time. Okay, excellent. Of course, you probably want to put a few more decimal places in here so we can see what it's doing. But it's gone down here and it's successfully put into these cells the square root of the cell in column A. Now, what I want to show you is what happens if you cause a problem for Excel by putting a minus number in there. Of course, there's no square root of a minus number, so there should be an error message now. I think the same will probably happen if you put a text value in there as well. Before I run it, I need to make sure that I get rid of these values. And there we go. So the macro has gone down here to the fourth cell and it's trying to find the square root of minus 16, which it can't. So we've got this error message coming up which says, well, it's slightly apologetic, sorry about this here. It says an error occurred. I've got the following info. The macro can go to row 1, the macro goes to row 2, the macro goes to row 3. So I can see there's another bug in there, but the point is that we've managed to get ourselves an error message which tells us something about what's gone wrong with the macro, and if it was a more complicated one than this, that might be quite helpful. I am going to go and just get that to run properly because it annoys me that I didn't think of that. So an error occurred, I've got the following information, the macro goes to row 3. Well, you can see that anyway, but that's a good example of how to make code branch.